So, thank you everyone for coming to my talk. I know that it can be a little bit challenging because you all ate like 1 hour ago. So, nevertheless, I'm gonna to take your time and try to infect you with idea of Terraform and how cool is it, and especially in security and in delivery pipelines and how to make them. So we'll start from basic things like what is Terraform. I really will not spend significant amount of time on that because this topic was supposed to be level 3, so I have to ask who use Terraform right now? Cool, so half of people at least. And this means that you are in the right place because this talk will be almost nothing about basics of Terraform, really. So we'll also talk about what is CI/CD, also assuming that you know most of it already because there were lots of talks about this stuff. And the most helpful part for practitioners should be the last one, where will be frequent Terraform problems. It's like new definition of FTP. So let's get started. First of all, a couple words about myself. I worked for about 3 years with Terraform and AWS, even more. So I became fully certified in AWS and then figured out that there is Terraform, and Terraform has a concept of modules. So modules is something what is like building blocks in Terraform. So I started contributing 3 years ago to Terraform community modules, which turned out to be pretty popular. And as of now, Terraform AWS modules, which I wrote and maintain, are downloaded several 100,000 times. So this means that a lot of people use it either for deploying their infrastructure or by just pinging GitHub API, which triggers count to grow. I don't know. But the funny thing is that there are some modules which were downloaded about 500,000 of times. And this is just growing if you click refresh page. So it's pretty cool. I also work on Modules TF is my hobby project where I want to give a possibility for everyone to actually build their own infrastructure modules using Terraform. And yeah, I sometimes use Twitter, but not so much. So anyway, I'm very eager to get any questions if you have. During this talk, especially later, to get some stickers and even later using some of these. So Terraform, as half of you already know what is it, I just want to say that this is a tool written by HashiCorp in order to write, plan, and create infrastructure as code. So the full documentation is available online. I'm not going to repeat really basics here. This is a typical 2-tier or multi-tier AWS infrastructure, which consists of some components like elastic load balancer, auto-scaling groups, and so on. And to get from this one into this one, this is actually how Terraform configuration looks like, we have to script it. So we have to write this file, we have to define what kind of variables we need, what kind of providers we use in which region, and so on. So this particular piece of code will create a S3 bucket with some random name in it and output it at the end. To get this code running, you have to first run Terraform init, which will download some dependencies like AWS provider. And then you have to run apply. So apply in latest version will just tell you what's going to be happening, and then it will apply it. And as the last line, at the very end, you can see that it outputs the bucket which was created. So that's all about Terraform, really. So why CI/CD pipeline are important? And the key factor is why they're important is that they help us to identify bottlenecks. And bottlenecks is very easy to identify if you perform the same operations over and over and you see some differences. So this is how typical CI/CD pipeline look like. As starting from the left part, developers create some code, then automated CI pipeline is executed where this code is built, then run unit tests, integration tests, and so on. And then we are going to continuous delivery and continuous deployment pipelines where code is actually reviewed and deployed to to stage environment, most likely in automated way, and then eventually to production environment, maybe with help of human. So how to get started with Terraform actually from 0 to 1? It's easier. You read documentation, you write some code, and you run Terraform Apply. That's it. But it's not always that easy, because often there is a situation where it works on my machine but doesn't work on someone else's machine, or even more funny situations can be that I'm using Mac, you're using Windows, so welcome to line endings problem, and so on. So this is still like one of challenging part. So you will eventually figure out that it's better to run in central place. So you start to think, okay, my code is not so good because I just created a bunch of resources and it suddenly start to become spaghetti code. So then you go to documentation, read about Terraform modules, and actually modules is the minimum granular bit of Terraform which you have to use. And most likely you should not invent it. So I really recommend you to take a look into Registry Terraform.io, where there are at least 300 modules for different providers for different problems exist. Especially if this is common problem, like you need to set up VPC in AWS, or you need to have auto-scaling group or elastic load balancer and so on, or even security group with some predefined rules. So this is in particular what I maintain and what people are using a lot. I'm quite certain that there are at least some people here who have been using this before, but maybe you don't know this. So thank you very much for that. So Terraform Workspace, the second feature which is kind of built in Terraform, but my only suggestion is this, that never use this. Because Terraform Workspace will created to isolate some of resources for you. And for me, it diminished the whole purpose of infrastructure as code, that your infrastructure is there, but it's hidden. So for example, in order to switch workspace and say that now you're working with these resources, but in different workspace, you can run this command, but this command will not be traced anywhere. So there is no way to commit this code, commit this code so that we can compare workspace A and workspace B. So I really against this feature, so that's why end of file. Next one. So CI/CD tools. In general, there are plenty of them. There are hosted one, which I really prefer to use because I'm lazy and I don't like to manage anything. Even some people pay me to do that. But I really like to use Circle CI and Travis CI. And quite recently, there were some active development happening even in Ansible, that there is plugin for Terraform, but more people are leaning toward Concourse. So talking about Terraform-specific solutions for workflow is Atlantis. Atlantis is open source project written in Go, has several hundreds of stars on GitHub. People are actively wishing that this project continue to grow and develop further. Unfortunately, it's pretty hard because there is just one full-time guy who's maintaining it. So if you are looking for ways to automate your workflow, please take a look on this project and give some love to this one, or open an issue. So if you have money, Terraform Enterprise is most likely your choice because it's about enterprise pricing. Quite a recent addition to this Terraform Enterprise were private modules registry, which means that if you have a company where you have some specific Terraform modules which you don't want to share with anyone else, for example, it can be module which create infrastructure just your way. So no one should care about this. So you can use private modules registry. But in a nutshell, it's just a GUI for Terraform open source, which allows to do basic things like plan, apply, prevent lock-in, or actually enforce lock-in, and do some state rollbacks and so on. But again, I would not put this as most recommended option because you should be able to become familiar with Terraform open source in first place before you can figure out where to spend money. So first part of pre-summary is that we know, or at least we saw 3 slides about how Terraform code looks like. There are some CI/CD options, so let's see what's next. So next we have to look into what are different, I kind of not sure that I really like word gotcha. After I submitted this talk, I figured out that that's actually not the right word. But anyway, so what are common challenges with putting Terraform in CI/CD pipeline? So since the tool was written for command line usage in first place, it means that operator has to be nearby, because if there is an error during the execution of Terraform, it will not roll back to previous known state. It will just keep things as is, and you will have to fix this somehow yourself. Also, there are different consistency problems which can be fixed by telling Terraform to execute this piece of code just with parallel equal 1, means that only one call to your cloud provider or to your other provider will be at the same time. This is pretty helpful if you want to debug some problem and you think this is because of consistency. Also, once you using Terraform from CI/CD pipeline, you have to take into account that there are differences between different places where it's run, whether it's run from developer's machine or whether it's run from CI server. So the metadata and all downloaded providers can be shared between different executions of Terraform. So if you really willing to increase performance of running Terraform on CI/CD pipeline, you have to cache the whole .terraform folder and use plugin cache for providers. One of the tricky part, which I realize maybe in a bad way, is that if you rely on some private registry, let's say you start using code from private registry, and even if you fork this module yourself and you think that you are safe, so that now I'm using my own copy, the owner still has possibility to, if he decides to delete this module, your fork will be also gone, which is pretty surprising. So forking of public repositories is good, or not good, but it doesn't have any consequences. But forking private repositories can be challenging. So that's why people prefer to fork public repositories and manage it themselves, just to make sure that they always have copy of their modules. So secrets. Secrets is a big, interesting part of CI/CD process in general. Luckily, most CI systems have solution for that. So they most likely have possibility to expose it as Terraform can read it using environment variables. But at the end, it will be still stored in plain text in state file. So for those who don't know, all information about resources which Terraform knows about is stored in plain JSON file. So this JSON file can be either locally or it can be stored on remote state. Working with CI/CD pipelines, it must be on remote state. So you should not keep anything close to the system itself. So, and several providers understand that keeping secrets in not encrypted way is bad. So PGP is possible to use if create AWS IAM user and login profile or access key. So this means that keys will be encrypted using PGP key, using keybase.io, for example. Or you can use RDS specific features by allowing IAM users to authenticate. But most popular solution is to actually set dummy password in Terraform and change it outside of it. So to not keep any real password in any place. So I don't know what is on this slide. Yes, so this slide is about one tricky part of Terraform. So when you put when you put resource like random string, because this is going to be my 10 random characters and password, and I'm okay that this file will be saved in state file. I mean, this password will be saved in state file, but it's not okay that when I run Terraform Apply, I actually can see it, because ID, where JQ less minus less, is actually a password. So this is visible for me, for operator, for anyone who can have access to this CI/CD, which is pretty bad. So yeah, as common sense. So when talking about security in general, most of us, I guess, know that principle of least privilege makes sense. And in terms of AWS, it means that one of identity and access management best practices tells that grant only the permission required to perform a task. So, which is fine, but in reality with Terraform, we look into this the following way, is that you only need permission, minimum permission when you need this. So for example, if you are running Terraform init, you're not gonna to need possibility to change resources like Route 53 DNS or EC2 instance. So that's why you just need to assume role passing your IAM credentials. If you are going to actually apply these changes, or if you're going to destroy some infrastructure, then yes, you have to provide your MFA token as well and assume another role. So that's the biggest takeaway. So this bag, for those who don't know, is takeaway. So that's one of takeaway from this presentation. So second one, access control is kind of clear. I mean, you assume whatever you need and just use it. But talking about security, I really like to mention that security is not just about access control. It's very often about, are you really thinking about running this code, or maybe not? So there are pull request approval systems which are not so popular yet. Maybe it will become suddenly part of GitHub native tooling. But right now, you have to use something else. So that checks out project by Capital One, for example, it allows to specify what kind of users are allowed to actually merge this code, so that you can say that you are allowed if you change something in this folder, you are not allowed if you change in this folder, and so on. It's not so sophisticated as I would like it to have, but it's better than nothing. For example, code owner's file allows just to merge pull request or review pull request. And it tightly depends on how you actually structure your code. If you have everything in one repository where everything is just like big spaghetti, sorry, but there is no solution. It's like, so we are going to do a little bit deeper dive into Terraform design patterns, the way I think about them. So there are 3 different design patterns and 3 different ways how to structure code. So first of all is resource module, and then infrastructure module and composition. So this should be understand just in this order. So resource modules, the main goal of them is just to create resources, really, nothing fancy, but they have to create it in very flexible way. And once you put all of your resources and variables and outputs and make this as a module, then you can version this. So that's exactly what Terraform AWS modules is mostly of. There are some exceptions, but primarily Terraform AWS modules is just that. So the second group is Terraform infrastructure module. This is like combination of your Terraform resource modules where you can apply some general standards. For example, in company where I currently consult with, we have infrastructure module which consists of one or several resource module, and we enforce tagging and naming, and we sometimes use code generator to fulfill missing parts of Terraform, like JSONnet or even cookie cutter to generate certain folders within this module. So this is pretty greenfield area, and I cannot recommend this like publicly, but nevertheless, this is a solution which we have to do to fulfill missing parts. And missing parts, you can go to Terraform GitHub issues, and you will see a lot of issues people are opening which are related to HCL limitations. So this is just a solution for them. And again, infrastructure modules can be versioned differently the way you want, not necessarily semantic versioning. And composition is like combination of this stuff, infrastructure and resource. And is there anyone who know what is Grant? Yeah, one. So Grant is awesome. Grant is awesome because it allows to write really small amount of code and reuse a lot of different good practices and best practices. So link will be there, so I encourage you to check if you are in the stage where you want to make something really, really reusable and following dry principles, and yeah, highly recommend. So basic pipelines looks primarily, this is just a repeat for those who didn't attend any sessions about this before, during this conference even. So developer work on his own feature branch and commit code, push this code, then he opens pull request, and this pull request is from his branch into the master branch, and once pull request is approved, then it got merged into master, and master actually run Terraform Apply on staging or production environment depending on situation. So as I mentioned earlier, I like to use something what I don't have to manage. So in this example, this is sample pipeline which I use based on Circle CI. So first step is to test if infrastructure code is at all exists and fine. Then I validate infrastructure using TF, lint, and some other tooling. I will show this next slides. Then I run plan. Terraform plan is sent as a command to GitHub pull request. Then if this is code in master branch, then I ask human to approve, because does it make sense to you to be deployed? He says yes, and then I apply this change in production. So pipelines for modules are slightly different than for almost anything else, because here, as I said, we generate missing configuration using JSON-add. We run some automated tests. In Terraform, there is a tool called Kitchen Terraform, which has pretty good support and pretty good integration with Terraform, which allows you to write inspect test similar to server spec. And yeah, and if you have dependencies on your module, even within organization, you can notify them somehow. This is something what I still couldn't figure out, like how to do this effectively, because not all changes should be notified everywhere. But still, change log or telling people on Slack or Twitter or whatever is a good idea for people to bring this awareness. So there are a few tools about this which I wrote here. So yeah, we are almost done. But this is pretty cool slogan. Lots of people agree that Terraform can be automated, let's put it everywhere, but it's not always like this, really. There are a lot of situations where Terraform cannot be placed in CI/CD pipeline and you have to invent something else. So pipelines are good, but unfortunately not enough, as was already mentioned on several talks before, that pipelines can be good, but there are still need for the human. So for example, if you want to refactor your Terraform code, or if you even want to upgrade your Terraform version or provider, or even version of module or anything, literally, you need human. It's pretty impossible to make it automated and secure. And yeah, frequent Terraform problems. For those who don't know, this is one of quite recent subreddit about Terraform. So if you have any questions, feel free to ask there. But refactoring is pretty exciting for me, because I now work with many different projects, and every time when developer created some resource in one place, and he doesn't want to change this resource and kill it here and start it in another module. Or even more popular problem is when you have when you create IAM user and you create access key for him, then you decide to refactor your code. You don't want to recreate his access key just because it's hard for you to move it. So Terraform state MV is actually the first command which I put into Terrible. Terrible is by name is Terraform plus Ansible. So that's my new project where I put some time when I have, but I think that it can be a good idea to use power of Ansible to manage Terraform configuration, to do in particular refactoring tasks. So when it comes to Terraform upgrade, one of tool which I know, which I like to use is tf-env, which is similar to Ruby env and a few other env. This is a piece of code, for example, which you can use to roll back your Terraform state file to the previous version. Without this code, there is no native support in Terraform, so you have to either click in AWS console or you can just steal this code. So Terraform logs is something when you run Terraform Apply and then you just close your laptop, for example. And then another person will not be able to continue because you didn't finish your operation and Terraform think that you are still working on this feature. So Terraform force unlock allows you to do this. Unfortunately, it's pretty hard to automate it. And there can be very good reasons for you to lock this. Because if you are fixing on this problem, you don't want anyone else to come up and change the same resources at the same time. It will be just a mess. So, and Atlantis can help with this because it allows to lock code based on pull request. So we have some time and there will be some demo if internet works. Unfortunately, yesterday evening it didn't work. I mean, not internet, but this Circle CI suddenly raised lots of errors when I click on this page. So as you can see, it still doesn't work. But believe me, code works. So here is the code for this. So I have linked to this repository already. So this is a sample main TF file where configurations are defined, like which Terraform version you need, which provider you need, and which AMI or Amazon machine image you're going to use, and then call in couple Terraform AWS modules to create security group and to create EC2 instance. So that's all what this code is doing. And then it creates Elastic IP. So when we go to, I have already set up AWS access credential on this machine. So I can now run Terraform init from here. And yeah, of course. So something doesn't work with credentials or internet. No, yeah. No, it will not work this way. It's maybe now, no. It suddenly stopped working as usual. But believe me, it works. So what I just wanted to show is that this code is executed. If I run init, then I download dependencies. Then when I run apply, or I could run Terraform plan, but if I run Terraform apply, then I should see something like this. Yeah, exactly. So I should see what's going to be created, like Elastic IP address, EC2 instances, security group with a bunch of roles. And then when I type yes, then it's actually created. So this code is, and then at the end, output of IP address. And when I'm done playing with it, then I run Terraform destroy, and everything what was created is going to be destroyed. But I can do this manually. If I do refactoring, that's important for me to be able to do. But Circle CI has such configuration where pipeline is defined a sequence of steps, validate, run plan, make sure that human approve it, and then apply it if this is a master branch. So this is small pipeline which is executed right now for majority of projects where I work with. But again, I use Terraform Grant a lot, so I slightly modify this. So let's pretend that demo worked. So final summary for this talk is that CI/CD is good concept. It exists for a pretty long time, but it's good only for things which can be automated. And take it as granted that there are lots of tasks which cannot be automated. And it's very important that you have the same way of dealing with this, with executing the same code as you would be able to do on CI server. So you don't have to make things really complicated, like no workspace, no crazy arguments in command line interface. Even if Terraform allows you to specify -var and then key equal value 20 times, really keep it easy and keep it absolutely simple.